Should I start? Okay. So good morning, everyone. Thank you for being here. My name again is Victor Cheung, and I'm from Carleton University. Before I begin, I need to mention that this work is mostly based on the master thesis work from the first author, Elias, who unfortunately cannot make it to the conference, so I'm presenting work on behalf of everyone here. All right, so let me open with a takeaway message. We read a study with band gestures, and particularly in mobile games, and we noticed that in mobile games, players can learn the band gestures by discovery, and while pre-game training helps the initial learning of playing the game, it might not be essential in the long run, and I'll elaborate a little bit more through the presentation. So let's take a quick look at the two of the work that inspired or motivated our work in this paper. The first one is the deformation interaction, or in particular the band interaction. So we all know how to bend stuff. It's highly tangible, and research has shown that they are actually pretty good when you design games for band gestures. In most of the cases, most of the prior work, they implement the whole band gestures in a device that is entirely bendable, including the display itself. So here are two examples of the prior work that implement the whole band gestures, implement the whole game using band gestures. The other line of work that inspired our work is the around device interaction. Most of the time, these interactions are used to address touchscreen problems, issues such as occlusion problems or imprecision problems. But at the same time, they also allow us to have some novel interactivities, such as around device or mid-air gestures. Here are some works where the user can use the side of the device, on top of the device, or use widgets that can be anywhere around the device to control the interface on the display. So as you might have noticed from our title, we also look into learnability and memorability. We use these words to help us or guide us while we are designing our study approach. The first one is learnability. We in particular look at how people learn gestures. And from prior work, we know that we can split it into two parts for a person to learn how to perform the gesture itself and to make the association between the gesture and the action that happens in the interface. The other one is the guidance hypothesis, which says that if we provide a person too many guidance, then it will develop this dependency and the person will never actually learn how to use the gesture. Another part is the memorability, which is pretty straightforward. It's how much a person can retain that knowledge of the gesture. And in the literature, most of the time we test it at least after 1 week. So we will have some gesture taught, and then after 1 week we test it, whether the person can retain it. With all that, we create a flexible prototype, which you might have seen it in our demo session. If not, then you can see it later on. We use a regular rigid smartphone. We did not modify anything on the smartphone, but instead we create a flexible sleeve around the smartphone. The sleeve itself is made with flexible silicone, so it's very flexible. At the same time, we embed band sensors on the silicone case, particularly on the corners. So what it does is it can detect bands at the corners as well as the sides. So here is a quick video of the game that we developed using only the band gestures to play. So in the madness, you have seen the same video. It's sped up so that we can finish watching it in 30 seconds. But the idea is you use only the band gestures. You do not touch the screen at all. You do not issue any voice command or whatnot. And then you play the entire game by moving this paper. You fold it, you squeeze it, you crumple it. So it goes around obstacles like a ninja. So that's why it's called PaperNinja, if you wonder. And at the end, you will reach the recycling bin. Very educational. All right. So with that, let me just go to the next slide, which is this button. Yep, so we have the prototype, we have the game. As I mentioned, we were interested to see if someone can actually learn those band gestures, because after all, it's kind of like a novel interaction mechanism. So we have 3 pre-game training conditions. The first one, we only taught our participant how to perform the gestures, but that's it. Like you vote, and then that's it. The other condition, we also, on top of that, we taught them like what is going to happen within the game. So they know the mapping, the association with the gestures in the game. The third one is a baseline where they receive no training and they just play the game on the spot. A little bit more about the study itself. We recruited 30 participants and 11 female, mean age 23. And we applied we used a between subject design for the training types. That is, we had 10 participants out of the 30 to receive the gesture only training. 10 of them received both the mapping and the gesture training, and the rest did not receive any trainings. Because we also wanted to test the memorability, we had two sessions. The first one, we invited them in, do their corresponding training, asked them to play the game 3 times. And then we send them back home, and after 1 week, we invite them back in the session 2 and immediately ask them to play the game. So during the sessions, we collect 2 kinds of data. One is more related to the performance. So we collect completion time and the number of gestures being performed while playing the games. We also ask like a scale questions to gauge the perceived performance in both sessions. And at the end of the first session, we want to look at how much they are learning, how they feel about learning about the gestures. And at the end of the second session, we ask them how much they could recall those gestures. So here are some interesting results that we found. For more details, I refer you back to the paper itself. On the left-hand side is the completion time. On the right-hand side is the number of gestures performed across all the sessions and in the 3 game playing trials. We call them trials. The first interesting result is that if we provide the mapping on top of the gesture training, it actually led to a significantly better completion time and fewer gestures performed in the first trial. However, when we look at whether there's a difference between the conditions in terms of memorability, we did not find any significant results. Meaning that no matter what kind of training we provide, after some time, our participants actually pick up how to play the game in the end and remember how to play it. Another thing we found was that the participants, when they filled out that perceived performance at the end of session 1, those who receive only the gesture training rated the lowest confidence in performance, the perceived performance, which kind of interesting because it also is being reflected by the actual performance shown in the previous slide. So to conclude, from our study, we noticed our participants mentioned that bench gestures are fun, intuitive, easy to learn. Beginning training has some initial learning benefits, but has no lasting effect compared to others. But if we only tell them gesture, but without telling anything else, it leads to the worst actual and perceived performance. All right, so that brings us to the end of the presentation. Thank you for your attention, and please feel free to come check out the demo, and I'm happy to answer questions.
We have loads of time for questions.
It's crystal clear. All good.
Everything. So I will ask you just a simple question about have you tried comparing so these bend gestures and the vocabulary, and so the effect maybe on learnability and memorability compared to just orientation or even just gripping? Do you think that adds a tremendous amount of interactive capabilities, but also what you've been studying? Does that make a significant difference, you feel, compared to these basic motions?
Right, so we did not compare the bend gestures with, say, touch or orientation in this particular work, but I think there's some interesting thing going on when we combine all these things together. In this particular scenario, we have a game that kind of tailored towards bending, but I would imagine that later on, if we have some other more sophisticated games that you will have, combination of orientation stuff, then you have more control. You can more degree of freedoms to control the game. So even though we haven't compared that, I would speculate that it will have a better performance and also more engaging experience for players. All right.
All right. So if there are no more questions, let me thank our speaker again.